students. I'll welcome you to I will welcome you to the next session of the chapter, that is milling operations. Here in today's class we shall see the milling operations that are going to be performed on the milling machines. So why these are needed? We know that the products that are going to be produced in the lathe operation, they are basically the products that we produce on the lathe operations. They are generally going to be of cylindrical shapes, or they are going to be in the conical shapes. But in the realities, that is not all enough to have all kinds of the products that are going to be used in the real engineering applications. So there is a need to produce some grooves. There is a need to produce some slots in the uh, products. Okay. So for that reason, the milling operations are going to be very much essentials. So in milling operations, we are going to produce basically a rectangular surfaces. We are going to produce some inclined surfaces. We are going to produce some helical surfaces. Any other surface that is going to be required in the real applications. So basically, here it is, the products that we produce in the milling operations, they are basically of the triangular shapes, rectangular shape, even it may be concave shapes, convex shapes, or any other shapes. Okay, that is why these milling operations are going to are will find its applications in the material removal operations. Here there is a list of milling operations, that is plain milling, or even that is called as slab milling. Next is end milling, form milling, angular milling, slot milling, straddle milling, and gang milling. Okay, let us discuss one by one all these operations. The first one that comes across is the plane or slab milling operation. Okay, here in examination, or the characteristics of all these operations are nothing but the relative motion between the tool and workpiece. Okay, here workpiece, as we know in milling operations, the workpiece is going to be clamped, it will not be moving. Okay, only the tool is going to be rotating, and the workpiece is going to be fed against the rotation of the tool. That is the basic for any milling operation. But the edges of the teeth, or the point of contact, how they are going to look like, okay, will be classified accordingly. Okay, now in the plane operation, what happens is, in the plane milling operation, here the characteristics of this milling operation, this plane operation is, here the width of the tool, right? The width of the tool is going to be more than the width of the workpiece. That is how it is characterized. Okay, so the width of the tool is going to be larger than the width of the workpiece. And here if you see the diagram, you will come to know this is going to be done on the horizontal axis, or means it is going to be performed on horizontal milling machine. Okay, the products that you produced in the milling operations, generally they are of rectangular shapes. This is about milling, plane milling operation. Next one is end milling. In the end milling, what we look at is, here the width of the tool is very small if you compare to the total width of the workpiece, and here the rotation of the tool is going to be vertical. That is why this end milling is done on the vertical milling machine, and this end milling is going to be done, or is going to be used for producing the slots, grooves, or keyways on the products. right? This is about end milling. So next one is slot milling. Here what happens is, again if you see this, okay, if you see the slot milling, right, the application wise the end milling and slot milling they are same, right? Even in the slot milling I am going to use this slot milling to produce the keys, screws or the slots. But here the axis of the rotation of the tool is horizontal and the width of the tool is small compared to the width of the workpiece. Okay, right? And next is, here you can see the edge of the teeth, right? The edge of the teeth is parallel to the axis of the tool, right? The one more characteristics of this slot milling is the edge of the teeth is parallel to the axis of the tool, right? So this is all about slot milling. Okay, once the tool starts rotating, if you feed the work against to the rotation, right? So this is going to remove the excess material from the workpiece, right? Again, the products that you produce are generally of rectangular surfaces. Okay, right? This is about slot milling. Then the next milling operation is form milling, right? In form milling, again the axis of rotation is horizontal, so it is going to be done on the horizontal milling machine. And here if you see the edge, right, the cutting edge of the teeth are they are going to be not straight, right? They are going to be bent, right? They are bent convex, right? They are going to be bent in the shape of convex shape with respect to the axis of the tool, right? Here you can see, right, this is convex, this is also bent, this is also bent and this is also bent. That is why, so the form milling is the operation to produce the irregular contours or the shapes by using the form cutters, right? So here the irregular shapes may be the convex, okay, it may be concave in the nature or any other shapes, right? So here the products that you produce in the form milling, they are not rectangular in shapes, they are going to be in the convex or concave shapes in the on the milling products, right? So here also this is going to be done on the horizontal milling machine, right? This is about form milling. Next is angular milling. Here in the angular milling, again the axis of rotation is horizontal, so it is done on the horizontal milling machine. And here if you see the cutting edges, right, they are going to make some angle with the axis, right? That is why it is called as angular milling. So these cutting edges are making some angle with the axis of tool, that is why it is called as angular milling, right? So here this milling operation is going to be used to produce the V shapes or the triangular shapes on the milling on the workpieces that you desire. Okay, again because axis of rotation is horizontal, it is done on the horizontal milling machine. Okay, the next one is straddle milling, right? So here the straddle milling is used to produce the flat vertical surfaces on both sides of the workpiece, right? So I'll just go back to the slot milling. Here also you are producing the vertical surfaces only, right? Here also you are producing the vertical surfaces, but here the slots or the material where you remove it will not be at the end of the workpiece, right? It is at the center or it may be in between the surface. But so here in the straddle milling, you are going to remove the material on either side of the workpiece, right? So here the straddle milling has a special arrangement that you have to see, right? So here the axis of rotation means this is the arbor, right? Arbor is nothing but it is the shaft. On the shaft you are going to mount two different what you call the slot millers, means slot cutters, right? This is one slot cutter and this is also one slot cutter. But here between these two slot cutters there is a spacer, means that spacer is going to be equal to the distance that should be had to have a proper distance for the cutting action to take place. Okay, but one more thing is here the diameter of the two cutters that you have used must be equal to each other, means they should be of same diameter if you are making use of straddle milling. Okay, so here in the straddle milling, let us summarize. Here straddle milling is used for producing the flat vertical surfaces. Okay, and these are mounted on the ends of the workpiece, and there is a spacer. The distance, the width of this spacer must be equal to the width to be maintained by the workpiece to produce the product. Okay, right, the axis of rotation is again horizontal. Okay, right, and the diameter of the two tools that you have used must be equal. This is about the straddle milling. So if you make use of straddle milling, you are going to end up with having the vertical surfaces at the end of the end surface of the workpiece, right? The next one is gang milling. The difference is not much between the straddle and gang milling. Here also the most of the part is same, but here what I will have is, again there is a arbor. On the arbor I will keep 1, 2, 3, 4, 5 cutters, right? Here I am keeping 5 different cutters. Okay, this the end cutters that I have used here. Okay, and the other end of the arrangement, they are of same diameters, right? This diameter and this diameter is same. The next two cutters are of same diameter. The diameter which is at the center, okay, right, it is of again a different diameter. So what I can conclude here is, on gang milling you can use any different diameters of the tools so that you can produce a workpiece of desired shape, right? That is what I have mentioned here, right? Here on the gang milling you can use same or different diameters of the workpiece can be mounted on the arbor, right? Here you can see all of different diameters, right? So the method saves most of the time that can be used to produce in different ways, right? Means if at all I want to produce the product of this shape, I could have gone 3 different operation if the gang milling was not in implementation, means, right? So if these two are removed, okay, I could have removed the material at the end, right? So again you have to bring the tool, again you have to cut here, right? So again if you want to cut, again one more action to be performed to remove the material at the center. So the gang milling makes sure you are going to save most of the time unnecessarily that you have wasted during the clamping and unclamping of the tool and workpiece, most of the applications, right? This is about gang milling, right? Again in the gang milling this is used for horizontal milling operations, right? So let us see some of the videos related to gang milling so that we'll get a very basic idea of all this applications. Okay, right? So here is a video that I wanted to show for all of you, right? So I wanted to show the working animation of straddle milling. Okay, here if I show the view of this, right, this is the cutter, right? This is also a cutter, right? So now what I'll do, I'll make this arbor to rotate. Okay, once this arbor starts rotating, this will also rotate the tool, right? The characteristic of Straddle milling is the diameter of both the cutters that you have mounted on the arbor as are going to be same. Okay, so here you are going to get the you are going to get the flat vertical surfaces, right? You just see the video for the straddle milling. Yes, this is the workpiece where I want to cut the shape. Here in this video, you'll come to know you'll get a stepped contour or the cut on the workpiece at the sides of the workpiece. That is what the prominence or the importance of this particular straddle milling operation. Right? The next operation is gang milling. That as I have already discussed. Here what happens, unlike in the straddle milling, the cutters that you have already used, okay, will have a same diameter, but here in the gang milling you can have any different diameters of the cutter, right? That is the main difference with the straddle milling. Okay, I'll show the video of this gang milling working. So this is the arbor. On the arbor, you have put three cutters of different diameters. Okay, right? You can see again at the end you will be having a stepped cut. Okay, at the sides of the workpiece, and now here the difference with the straddle milling in the gang milling is that okay, here there is a extra cut that you can do at the center of the workpiece, right? This is how the workpiece looks like after gang milling, and this saves lot of machining time. Next I want to discuss is form milling. Okay, in the form milling, right? Again, it is a horizontal milling operation, and if you see the cutter, okay, the edge of this cutter, okay, is going to be of concave shapes, right? So they are going to be of concave shapes, right? Now, if the workpiece is brought near in contact with the tool, right? So, because the shape of the cutters are concave, so you are going to have a concave shape on the workpiece. This is about the uh, formula. Okay, so this is end milling that I have already discussed. End milling is going to be done on the vertical axis, right? The rotation is vertical and workpiece is bent against the rotation of the tool, right? So the thing is here, if you see the diameter of the workpiece and the width of the sorry, if you see the diameter of the tool and the width of the workpiece, right, they are very much different, right? So the width or the diameter of the tool is very small compared to the width of the workpiece. The last operation that I want to show is angular milling. Okay, here these cutting edges will make some angle with the axis of the cutter. Once this cutter starts rotating, and if you bring the workpiece in contact with the cutter, right? So this cutter starts chipping away the extra material from the workpiece. Right? This is how the uh, the cutter looks like. Okay, and this is the workpiece, and it is going to be done on the horizontal milling operation. Right. So if you see the cut, once you know, if you see the profile of the cut is almost like a triangular shape, right? As I have discussed in the theory part, here also you will get a triangular shape once the machining process is going to be carried out. So this completes the chapter of milling in the module number 5. Thank you for joining in.